Hey everyone, ahead of this episode I just wanted to apologize for some of the audio quality. It appears that my microphone was a little bit close to the edge of my shirt, so it was adding this noise a little bit, but it's a pretty good episode, so I would say it's definitely worth soldiering through and finding out how much of your degree you may use in your life as an engineer. Thanks for watching. Hello everyone, and welcome to the SarioDev show, Engineering IRL. In today's revision, what we're going to be covering is how much of my uni degree is used in everyday engineering. So, for a bit of context, I studied a 5-year course at University of Technology, Sydney, called Computer Systems Engineering. So there's a main engineering major, and then there's different sub-majors. Now, for me, it's kind of interesting because where I work is predominantly electrical engineers, and for myself, being a computer systems engineer, my specialization is a little bit different. Now, if you remember way back, and probably this is more relevant to the younger guys, when you start out engineering, there is so much math, physics, and you do so many raw numbers. And to answer the first question straight up is, have I used any of those? Have I used derivatives? Have I done matrices? Have I done big functions? Not once. Not once. So the question is it important? Well, this is going to be the case with most of the subjects. The fundamentals are important. This is what everyone will tell you out there. Is like, yeah, the fundamentals and understanding the concepts is probably more valuable in itself. And then knowing that you could do the raw math if necessary. But truth be told, it's much like you in studying your mathematics courses now and subjects now, is that you will use a calculator for basic math. Okay, so the amount of times that we've got several super smart engineers who can work out the most complex problems, and someone has to whip out a calculator for 37.5 divided by 2. It's not that rare. So, from that standpoint, from the raw output, just like that calculator example, and you never do that, you really don't. Now you could, you might, depending on what engineering role you get. But in reality, you have to think about this. What function or what the type of engineering that's happening, what is their output? What is their goal? What makes them money? What's the business? What's the business case? And if you're R&D, you might go to those levels, but we have this thing called, they invented it recently, it's called computers. And they can do all the big, complicated math. All the equations are there. You Google it, there's Wolfram Alpha, there's all sorts of stuff that takes care of those type of things for you. A lot of the time the question is when to use it or whatever, but just keep in perspective, you have to prove you're able to solve this type of stuff. And this is why they say please get degrees, okay? Because once you get out into the field, once you become an engineer, let me put it this way, the number of times that someone has asked me what scores that I got in university have also been 0. No one cares. The question is, what can you do for me? Can you solve this problem? We've got to do these 8 things. How many of these tasks will you be helpful to me for? That's going to be more important. Your versatility, your ability to adapt. Now, if you're in R&D role, then obviously, depending on what you're researching, then you may come into to using more of your direct math skills. But even then, I would say that it's so specialized that you shouldn't worry about it from this standpoint. Oh, am I going to use this anyway? You got to pass it to get out anyway. So there's no point complaining if you're going to use it or not. But I can tell you that it's rarely. But I can also tell you that the foundation is important. Now, math's not the only subject. Once you do all your core subjects, your physics and all those common engineering strand ones, then you get into your major. And for me, my major did cross over with electrical a little bit, just for some specific subjects, mostly around controls, signals, and things like that. And then it also crosses over into the software world, software engineering world, but mostly around embedded applications. Yeah, so I program electrical stuff to do stuff. Now, once you get to your major, even that, you kind of use, there's a lot of communication subjects. Communication subjects you use, but a lot of them feel more like common sense. I feel like a lot of that, the communication skills is good for some people, but I found that learning on the job in your own company's culture, and you learn how people, how engineers interact with customers, how engineers interact with other engineers, based on when you're just CC'd in different emails and you just read through the email trail. I would say it's the main thing you learn from, the main thing you should take away from some of the communications courses is to be thoughtful and just aware of who is your audience. That's it. The problem is when they go into these details, the micro of the formalities, you need to have the structure this way, and that doesn't matter as much because that can change. So don't get caught up. For me, what in uni you get taught a bunch of micro details, like how-tos and specific details on how to actually do certain things and use certain tools. But what you need to understand is the macro, the why that these tools exist, or why you're learning certain techniques, more so because that's what actually carries through. The macro side is the part that carries through, not the micro, how do I do this? But it's good to know you have these skills, these mad skills to solve 5-page equations for 1 mark. It's cool, it's good. Now, so now we've gone to the major. The major, it kind of ties everything and gives you an idea of what your engineering specialization might be. Depends on the major, obviously. I can only speak from the major that I studied. But then, for the way my course was structured, computer systems really came alive at the sub-major level. And at the sub-major level, I found that the subjects that were there were definitely my favorites in the course overall. And they applied a lot more. But I can say even then, because of the role that I ended up with, which was control systems engineer, a lot of the skills were very useful, but only for useful, it was more useful for me trying to expand the type of things that we're doing outside of the main role. Okay, so because I had skills and I was taught in a different type of engineering, when thinking outside of the box is really where this came in, really where I could use some of these skills. And a lot of that's on like systems design and architectures and things like that. Sometimes what happens in the office, even as an engineer, you end up creating productivity tools or things that will help improve the process. There'll be existing processes everywhere. You're gonna love that. But there is opportunity to try and make processes more efficient. And that's on you. A lot of that stuff ends up coming out of your own time. You would have remembered from the earlier episode that I talked about how doing both at once, doing the way that the task that has been given to you, and then maybe the way that you think will be faster. So a lot of it will come out of your time. I will say that the problem solving that comes out of it and learning how to learn so quickly and absorbing things, that was really useful. Also, because you're fresh out of uni, you understand how to make a professional looking document. So I know everyone gets tired of writing documents and want to get to the practical stuff, but one of the practical things is documenting, unfortunately. But actually, the more you stay in the engineering game, the more you'll appreciate your documentation skills. But again, at first it's just a tool of, I can help. An engineer might do a whole bunch of works. They have to compile all their stuff and then document it for presentation to a customer or whatever it is. That's where you might come in early days, is to collate the work and then prepare some documentation for other engineers. But then later on, when you're designing documentation, right? Designing documentation, woo, it's actually a useful skill to have. But you'll apply that with other skills as well, and then depending on how your company is structured, or if you're a small company, then you have even more to do. So now you can see that there's a fair amount. You might get lucky. Your course might directly apply to what you're doing. But it's not that important, in my opinion, that the skill the tools that you learned at the time are exactly what you're going to be doing out in the field. It's advantageous. But what I'll say is, some of these these soft skills that you can earn is actually in your electives. A lot of people pick electives based on, this is the easiest thing to pass in the world, which is fine. I get that. You might be working at the same time or something like that. But with my ones, I chose to pick areas that wasn't directly in the course, but I figured might be useful skills. So I picked up one database course, and then I picked up another programming course, more software-based course. And now in my job, even though I'm not a software engineer or I'm not there for databases, because of those skills, I was able to upgrade a bunch of the old, a bunch of notepads or Excel files that have been used for data storage, and design some database systems to actually manage that kind of data. And because it was kind of second nature, it could get done correctly, and you're already reaping benefits pretty fast as well. That's just one example. So the other thing I picked up along the way was risk management in engineering. That had two things going for it. One, yes, it could be an elective. Two, it could be done over the summer. Three, it's a course that is in the master's engineering degree course that you can directly credit and not have to do if you ever decide to do your master's. I have not had to use that card yet, but I will tell you that course, for example, was not bad. There was some tools in there that when we're doing risk, you're doing a risk analysis of certain things, it always comes up in engineering. And sometimes it can be looked at as a little bit of not a throwaway, but you get given one to assess, and you're just kind of going off the top of your head. It feels not that tangible, but it's actually a skill that you can get better at. And then also, even your more senior engineers at the time, you can contribute to that topic, because it's just trying to think of everything to do with the project and the potential risks. And then you may not know how to mitigate everything, but you will eventually. You will. So I think a lot of soft skills were very, very useful. But I'm gonna leave you with this, is that in the degree, and don't worry if there's further questions, I can go in more detail with specific subjects that I've directly used and how. But for now, I'll stick to this level, because it's kind of a big topic, but also kind of not, because your degree is irrelevant. Sorry guys, what's going to matter is how you perform, how you learn, and how you work with other people. Your EQ will matter as much as your IQ, I'll put it that way. For real success, either you're that much smarter than everyone else and you're that good and that skilled that it demands that if you have low EQ, it's not that important, but in most cases, EQ is so important and your communication skills are so important because everyone already knows all the stuff. And typically, from my standpoint, it's great having so many engineers smarter than you in different topics, different scopes, because that's not all on you then. You have somewhere to go, and then you just find your niche that you're the expert at. You don't need to be the expert at everything. So, again, your course won't matter that much. You will gain the mental fortitude to dig deep, yeah, to look for longer solutions, to be able to map that out if necessary, to write the documentation necessary. You'll learn all of that sort of stuff, and then in your specific strands, I know there's a lot of calculations you do, and they are important for understanding, but you'll learn so much more from your experience on the job, what you specifically need to do. And there's a lot of programs, and a lot of the engineering is already proven. A lot of the physics is proven. What you're doing is deciding which pieces need to go together. And the last part is, I think what you'll take for granted a little bit is the international standards and Australian standards. They, at the end of the day, there is so many of them that apply to so many things. Even in your job, you may not be told to refer to a specific standard, but it's sometimes a good idea to understand which one would apply in that area, but also understand that unless it's part of your contract, that might not be expected of you to meet by your employer. But it is good to keep in mind because it asks questions that you may not have asked before. So, in summary, if you're, and this is how I'll relate it back to in your real life. Like, so for young engineers, obviously what I'm saying is you learn it all, get through a piece, get degrees. If you excel in it, great. But don't forget your soft skills, and don't forget trying to understand the macro of why a course was even created as a course. What kind of need was it even addressing? And don't poo-poo too much the business courses, because at the end of the day, even if you're not trying to do your own startup or you don't care about the numbers, when you do the financial subject is super easy, or the business subject is super easy for engineers. What it does, don't underestimate it, because at the end of the day, as an engineer, you're employed for a business. And so having that mindset about the business goals can help, at least from a perception standpoint, how upper management looks at you. So don't sleep on those subjects. Gain your soft skills. And if you're, so for everyone else, you have to remember that whatever it is that you study, whatever it is that you do, you're learning about, you only get out what you put in. And so even a course that you know all the answers for, you can still gain something. It's up to you how hard you work to extract that lesson, or to gain something. And you might say, but then what's the point? You have to do it anyway. You've done the course, you need this tick, you're already there. So maximize what you're already learning, see what you can understand, and even if you're doing any other course it is in your career, if you can understand from a macro level the why of the course anyways, then that might be some value. It gives you a clue of the direction of where your company is going, all the good stuff like that. So without further ado, thank you for listening. Hopefully this has been useful for someone out there. If you're an up-and-coming engineer and you got questions about the course, maybe you're a UTS person, maybe you're studying in Australia as well, or if you're studying any technical field or anything at all, just let me know if you have any questions. And until the next one, thanks for listening.